Hello students, welcome back. Let's resume our discussion in section 4, the chain rule. Here's a chain rule, and here is a three-step process. Outside first, inside stay the same, and then multiply the derivatives of the inside like a dangling chain. Right here. Not inside. Inside stay the same. Like a dangling chain, it comes outside right here. And then we went through some elementary chain rule problem, applying just once. And then we went through some double chain rule problem, applying chain rule twice. Like those. And then let's go to even harder problems, combining chain rule with other differentiation rule. I think we went through the first problem here. Product rule and then chain rule. Outside first. Outer structure is product rule. A times B form. So product rule first, but B here is a composite function. So we have a chain rule applied to the second function like this. Okay, how about the next problem here? Square root of, and then we have a quotient there. This time, the outer function is 1/2 power function. Do you see that? Outer structure is a composite function, and then inside we have a quotient rule. So unlike the previous problem, we have to do product rule first and then the chain rule inside, because the rule is outside in, outside first. This time, chain rule first and then quotient rule. Again, the rule is the same, outside in, outside first. If you have a bunch of parentheses in algebra, what do? Inside first. Inside out. That used to be the rule. Not anymore. In calculus, it's backward. Outside in, outside first, and we go inside. Okay, alright, let's prepare this problem. G of u is, let's see, here's a fraction, and that thing to the 1/2 power. Let me extend the font a little bit. Okay, alright. Copy and paste that thing here, and then let's calculate the derivative. How does that work? Well, outer function is 1/2 power, so multiply by the power, and then subtract 1 from the power. Inside stays the same, so no change there. And then the chain part. I have to multiply the derivative of the inside. All good? Alright. And then we have to calculate the derivative of this. Oh boy, what is that? It's a quotient rule. Okay, let's do the quotient rule here. Alright. Quotient rule. Okay, I can do that. Quotient rule. So denominator squared, and in the numerator we have something big. So what goes to the numerator? The structure is u prime, the derivative, and then v, copying down, minus u, and then v prime. By the way, I shouldn't be using uv here. U is already taken. U is a variable here, so okay, alright, the derivative of the numerator times the denominator times the numerator times the derivative of the denominator. So parentheses, those are just copy and pasting. So let's go ahead and do that. That's this. Okay, all right. Structure is pretty much done. So we did a chain rule outside first. Inside stayed the same, and then the derivative of the inside. But the derivative of the inside requires a quotient rule. So we ended up getting this quotient rule structure. All right. The derivative of the numerator. 2u plus 2. How's that? And then the derivative of the denominator. 3u squared minus 3. Did I do this right? Even bigger font. Please check. Step 1, outer function, 1/2 came out, subtract 1 from the power. Okay, step 1 complete. And then inside never changes, alright? And let's go to step 2. And step 2 is this derivative of the inside. But then again, the derivative of the inside is a quotient rule. So denominator squared. And then we have the derivative of the numerator times the denominator, same. And the numerator is the same. And then the derivative of the denominator. So numerator, u squared plus 2u, that's 2u plus 2. And the denominator, u cubed minus 3u, so 3u squared minus 3. The others are all copying and pasting, so there you go. Okay, alright. That was a bit hard. It wasn't hard really. Just two differentiation rule as a matter of fact. I mean, chain rule first and a quotient rule. Just longer. So, don't be intimidated. Okay, one more here. Alright. Stop the playback and try on your own. Before starting, let me just rewrite this thing into a power form like this. And let's put some space in between. Okay, preparation complete. And then let's go ahead with the derivative computation. Okay, what do you do here? How do you calculate the derivative? First, we have to do the quotient rule because outer structure is a over b form. So what do you have? We have denominator squared. And then in the numerator, we have u prime v and uv prime. You're going to get this kind of structure. Makes sense. Okay, let's calculate the derivative u prime a bit later, copying and pasting first. So this entire denominator, you just copy and paste it here. And then entire numerator here, just copy and pasting here. Okay, so far so good. So this is u prime v minus uv prime form, the derivative of the numerator. And look at carefully, the derivative of numerator requires a chain rule. The derivative of y cubed, that's easy. That's just 3y squared. And the derivative of this one here, that's a chain rule. We have a composite function. So what do? 1/2, and this thing is the negative 1/2 power. Nothing changes inside. y squared plus 2y. And then we have to multiply the derivative of the inside. What's the derivative of the inside here this time? Y squared plus 2y. We have 2y plus 2. Did I complete the derivative computation here? Please check. And then this multiplication applies to this one only, not to this. That one's separate. Okay, next, let's take the derivative of this denominator. Derivative of 2y is just 2, no problem there. And then derivative of a log function, 1 over the inside. And then we have to multiply the derivative of the inside. What's inside? What's inside the logarithm? We have y squared plus 1. And then, what's the derivative of the inside? Inside, derivative of y squared plus 1, that's 2y. So you can write like this. A lot of students will write 2y on the numerator here. That's okay too. As a matter of fact, let's go ahead and do it. Oh, never mind. No, let's stop here. Let's keep this bracket structure so that that's the derivative computation. Now, if you use web-based calculator like Mathway or whatever and type this in and get that, it'll automatically simplify you and you're going to get something very different. Same, but very different. Now, where in the world is your justification there? How do you use the power rule? How did you use the chain rule? How did you use the quotient rule? What about the product rule? No explanation. So if you do not use all these rules and get whatever, you're not getting credit. I'm serious. With correct answer, maybe 2 point, 3 point at max, no more. And then if you just copy a calculator, then of course that's just a plagiarism, so it could be even worse. So make sure you sit down and do the derivative computation. It's important. If you cannot justify, and if you do not put all the justification according to the derivative rule, you're not getting credit. Okay, all right. So much for the first half of the chain rule. And then we have a bunch more. Maybe I should have separated this section into chain rule 1 and chain rule 2. Maybe I'll do just that. Cover up to here. And then cover from the second derivative. Okay, we are done with section 4. Next time, we'll do section 5.